Limits. Question number 1. Limit x tends to infinity. X minus 3 divided by x plus 2 whole power x equal to limit x tends to infinity. We can take common x from here, so x power x 1 minus 3 upon x whole power x whole divided by x power x in denominator also. So 1 plus 2 upon x power x. X power x will cancel out and we will be left with limit x tends to infinity 1 minus 3 upon x power x, and this can be written as 1 plus 2 upon x power minus x. Now we know that limit x tends to infinity 1 plus a upon x power x equal to e power a. So 1 minus 3 upon x power x will become e power minus 3. And here, if we write it 2 upon x as minus 2 and minus x. So, the second term will give e power minus 2. So, that will be e power minus 5, which is our answer. Now, consider question number 2. Question number 2 says, limit x tends to 0 root x square plus 1 minus 1 divided by root x square plus 9 minus 3. This is very simple question. Here we can rationalize numerator and denominator separately. So we get limit x tends to 0 root of x square plus 1 minus 1 divided by the root of x square plus 9 minus 3 times root x square plus 9 plus 3 divided by root x square plus 9 plus 3 times root x square plus 1 plus 1 divided by root x square plus 1 plus 1. So we will get limit x tends to 0 and this will become x square plus 1 minus 1 and x square plus 9 under root plus 3 divided by this will become x square plus 9 minus 9 times x square plus 1 under root plus 1. From here, 1 will cancel out, this 9 will cancel out, x square upon x square will also cancel out. And then we put x equal to 0. So from here, it will be 3 plus 3, 6, and here 1 plus 1, 2. So 6 upon 2, and that will give 3. So this is our answer. Consider question number 3. Question number 3 says, limit x tends to 0 e to the power 1 upon x minus 1 divided by e to the power 1 upon x plus 1, where x does not equal to 0. So we try to get LHL and RHL. So LHL, limit x tends to 0 minus and then e to the power 1 upon x minus 1 divided by e to the power 1 upon x plus 1. So it will become e to the power minus infinity minus 1 divided by e to the power minus infinity plus 1, which will give minus 1. Similarly, if we consider RHL, so limit x tends to 0 plus e to the power 1 upon x minus 1 divided by e to the power 1 upon x plus 1. So this will give e to the power infinity minus 1 divided by e to the power infinity plus 1. If we take e to the power infinity common, so we will be left with 1 minus 1 upon infinity divided by e to the power infinity and divided by e to the power infinity common. So 1 plus 1 upon e to the power infinity and e to the power infinity equal to infinity. So second term of each bracket will become 0 and e infinity will cancel out. So ultimately we will get 1, which is our answer. But here LHL is minus 1 and RHL is 1. So both limits are not equal. Hence limit does not exist. Let's consider question number 4. Question number 4 says limit x tends to 0, x cos x minus log 1 plus x divided by x square. Here we expand both the term. So we know that cos x is equal to 1 minus x square upon factorial 2 plus x power 4 upon factorial 4 and so on. And log 1 plus x gives x minus x square upon 2 plus x cube upon 3 minus x power 4 upon 4 and so on. So if we put these values, so limit x tends to 0, 1 upon x square times x times 1 minus x square upon factorial 2 plus x power 4 upon factorial 4 dot minus x plus x square upon 2 minus x cube upon 3 plus x power 4 upon 4 and so on. So here first term will cancel out and we can write it like x tends to 0, 1 upon x square. So x minus x cube by factorial 2 plus x power 5 by factorial 5, sorry, factorial 4 dot minus x plus x squared by 2 minus x cubed by 3 and so on. So here x will cancel out and when we divide by x square, so here x will be left, here x square will be left, here only 1 by 2 will be left and here there will be x. So all terms containing x will become 0 except this which will be 1 by 2. So our answer is 1 by 2. Now let's consider question number 5. Question number 5 says we are given greatest integer function and limit x tends to 0 plus x times 1 upon x greatest integer plus 2 upon x greatest integer till 15 upon x greatest integer. So let's evaluate it. Limit x tends to 0 plus x times greatest integer 1 upon x plus x times greatest integer 2 upon x plus dot plus x times greatest integer 15 upon x. So we will be left with 1 plus 2 plus 3 plus dot plus 15, which will be 15 into 16 divided by 2, that is 120, which is our answer. Now let's consider question number 6. Question number 6 says limit x tends to 0 sine pi cos square x divided by x square. So we can write it limit x tends to 0 sine pi times 1 minus sine square x whole divided by x square, limit x tends to 0, sine pi minus pi sine square x whole divided by x square. We know that sine pi minus theta is sine theta. So we get limit x tends to 0, sine pi sine square x divided by x square, which can be written as limit x tends to 0, sine pi sine square x whole divided by pi sine square x times pi sine square x divided by x square. So this term will become 0. This term will become 0. So we will get pi, which is our answer. Now consider question number 7. Question number 7 says limit x tends to 0, 1 minus cos 2x times 3 plus cos x divided by x tan 4x. So we write it limit x tends to 0. This can be written as 2 sine square x times 3 plus cos x divided by x tan 4x. We know the formula limit x tends to 0, sine x upon x equal to 1, limit x tends to 0, tan x upon x equal to 1. So we can write it limit x tends to 0 twice of sine x upon x whole square times, here I have divided by x square. So to cancel it, I can multiply by x square. Now this can be written 3 plus cos x divided by x times tan 4x divided by 4x multiplied by 4x. So this term will become 1. From here, this is x square, this is x square, so this will be cancelled out. So we will be left with limit x tends to 0, 2 times 3 plus cos x whole divided by 4. So if we put x equal to 0, so this term will become 4. So 2 into 4 divided by 4. That will give 2, which is our answer. Consider question number 8. Question number 8 says limit x tends to 2. Root of 1 minus cos 2 x minus 2 x minus 2 whole divided by x minus 2. Here we assume let x minus 2 equal to y. Now when x tends to 2, y tends to 0. So what do we get? We get limit y tends to 0, root of 1 minus cos 2y divided by y. So it will become limit y tends to 0, root of 2 sine square y divided by y. Now this will become root 2 times here limit y tends to 0 root 2 times modulus sine y divided by y. Now two cases arise. When y is less than 0, then sine y will become minus sine y. Modulus sine y will become minus sine y. In that case, limit will be LHL will be root 2 times minus 1. That is minus 2. And when y is greater than 0, then modulus sine y will become sine y. And then sine y upon y, when limit y tends to 0, will give 1. So in that case, RHL will be root 2. Since LHL and RHL are not equal, so limit does not exist. Let's consider next question. Question number 9. Question number 9 says limit x tends to pi by 2, 1 minus tan x by 2 times 1 minus sine x divided by 1 plus tan x by 2, which can be written as limit x tends to pi by 2. Here, 1 minus tan x by 2 divided by 1 plus tan x by 2 can be written as tan pi by 4 minus x by 2. And here we write sin x as cos pi by 2 minus x. So 1 minus cos pi by 2 minus x. And then we apply formula 1 minus cos theta, that is 2 sine square theta by 2. And here in denominator, I have missed denominator was having pi minus 2x whole cube. So here divided by pi minus 2x whole cube. Now we further write it limit x tends to pi by 2 tan pi by 4 minus x by 2 times. This will become 2 sine square pi by 4 minus x by 2. And from here, if we take common 4, then what do we get? 4 cube, then this will become pi by 4 minus x by 2 whole cube. So 2 and this 4 cube is 64. So that will give 1 upon 32 times limit x tends to pi by 2 tan pi by 4 minus x by 2 divided by pi by 4 minus x by 2 times sine pi by 4 minus x by 2 whole divided by pi by 4 minus x by 2 whole square. So this term, first term will give 1, this term will also give 1. So we will get 1 upon 32, which is our answer. Thank you.